My name is Mark Smith, although I'm known generally as GD2K online for reasons that aren't as amusing as you might imagine. I'm a developer advocate at a database company you may have heard of called MongoDB, and I've been asked to make something very clear. My employer does not use or endorse any of the techniques demonstrated in this presentation. Furthermore, I do not use or endorse any of the techniques demonstrated in this presentation. Any harm you cause to your physical person or to your career by using these techniques are entirely at your own discretion. Now, on every computer I've had for the past 20 years, I've created a folder called Stupid Python Tricks. I use it to try out features of Python in ways that wouldn't get past a code review because they're too silly or weird. I've lost some of this code over the years, which makes me sad. These days I store some of it in a GitHub project called Stupid Python Tricks. Every so often I like to take some of the code out, brush it off and show it to people to see how they respond. Now this talk is in two halves. There are essentially two stupid tricks using a handful of techniques, and in each half I'll try to describe the stupid thing I'm trying to do and then the thought process I took to actually getting it to work. First, in a moment, I'll introduce you to a library I wrote called Ish. I wrote it for a lightning talk at EuroPython 5 years ago, and it was just purely a joke, but it was quite popular and has now had multiple contributors. So let's talk about types in Python. I like types, and Python's very forgiving with them generally. For example, here's how you compare two Boolean values. As you'd expect, true is the same as true, and false is not equal to true. So comparing them gives false. And for historical reasons, 1 is equal to true, and 0 is equal to false. Now here's where it starts to get interesting. If I compare a string containing the word true to the Boolean value true, that works. Yes! The only problem is the word false also equals true. Well, this is not ideal. Ideally, what we want is a value that's a bit like true or false, but a bit more understanding when you try to compare it to other values. Something that's not necessarily true, but true-ish. This is the end result I want. I want to be able to suffix the word ish to either true or false, and I want to be able to compare that to different values and get something sensible. Now, you may be sitting there wondering, why would I want to do this thing? Well, if you're asking that question, then you might be in the wrong talk. So, back to what I want. But first, let's take a step backwards. Let's ignore the hyphen between true and ish for the moment and just try to create a value called true-ish that compares the way we want to. So, how do I change the way the equals operator works? So, let me show you what happens when you compare two values. Behind the scenes, first it calls this special EQ method on the left-hand value and passes it to the right-hand value as an argument. If this EQ method returns not implemented, it means that a string doesn't know how to compare itself to whatever true-ish is. So then Python will try the same thing, but the other way round. So my job here is to create a thing called true-ish with an EQ method, a dunder EQ method, that returns true when it's passed the string true. If you're relatively new to Python, you may be thinking, how do I know this? Well, it's described in this amazing document in the Python documentation called the Python data model. This document describes so much cool stuff that you can do with classes and different special methods and values. So many of my stupid tricks use things I learned in this one document. So here's the class I came up with. There are definitely better ways to write this, and the real version is a bit longer, but at heart it's quite simple. If the value that's been provided to the dunder EQ method looks truthy, then return true, because it's true-ish. If the value's falsy, then return false, because you know it's not true-ish. Otherwise, you have no idea whether the value that's been passed into this method is truthy or falsy. And so in this case, I raise a custom error called maybe, because I think it's kind of funny to have an exception called maybe. So let's try this out. Because most special methods only work on instances, I create an instance of my true-ish class, and then I check that it works against the true boolean. Yes, it works. Now, to compare it against a string containing the word true, and again, yes, it works. But you remember that this will work with just the standard true boolean. So a couple more tests. Compare against false should be false because it's not true-ish, and comparing against the false string is also false. And finally, to compare it to some nonsense, compare it against the string lemons, and it raises a maybe. Okay, but I'm not quite done. The way I want to use this is hyphenated, like this. Here's the syntax I set out at the beginning. You can see that this expression here looks like a hyphen, but actually it's a minus, a subtraction operator. Subtraction works in a similar way to equality, but it's slightly different. So when I attempt to subtract the ish variable from the value true, first it calls the dunder sub special function. This is described in the Python data model document. If that returns not implemented, which it will because the Python core developers never expected to subtract an ish from true, then it tries it the other way round. Only this time it calls rsub instead of sub. Rsub is the subtraction method, but where the thing being called is on the right-hand side of the subtraction. So I need ish to be an object that when rsub is called with true, returns a true-ish, and when rsub is called with false, it returns a false-ish. It turns out that this is relatively straightforward. It's really just an if statement. Now, note that I haven't shown you how to implement false-ish. A false-ish is just the same as true-ish, but it returns the opposite results. So let's try it out. First, I'll subtract ish from true. And the result is a true-ish instance. And if you are paying attention, you know that a true-ish can be compared to the string true. And it can be compared to the string false, which isn't true-ish. And we could do something similar with false-ish values, which match. All the code you've seen here has been extracted and simplified from this stupid library I wrote, which is on GitHub. If you enjoyed this, I recommend you check it out. It does a few things this code doesn't. For example, it supports slang and some words from different languages. It can also do fuzzy numeric comparisons. And I've recently removed this code to simplify things, but if you go back through the Git history, you'll find it. My friend Jeffrey French added a neural network to the library that allows you to compare image data to emotions like happy, sad, angry, etc. And it would tell you if the photo of a person roughly matches the emotion you specified. So, the main thing I've been getting at in this part of the talk is that these special or dunder methods and things like that are a way of changing the way Python behaves in subtle ways. They're ways of opening a hatch into the Python language and changing things. So here's what I've covered in this half. Well, I've shown you how you can change the way equality works with your object by implementing dunder EQ. I've also shown you how you can overload subtraction so that you can use minus as a hyphen. Pathlib, incidentally, does the same thing with division to allow you to join paths together. And finally, now you know about the Python data model document, which describes much of the magic that you can do with Python. And now we come to the second half of my talk, which I have called Fun with Math. If you want a reasonably accurate version of pi, you can access it through the math module. Here's what it looks like. Unfortunately, it's not an exact value, because everybody knows the correct value of pi is 3. Fortunately, you can fix the math module's behaviour. If you import math, you can just then assign a new value to math.pi. So now, in other parts of your codebase, if you import math and print out pi, you get the correct value of pi. Unfortunately, I found that in codebases where I've done this, for some reason my fellow developers can get upset. It's better to sneak in the correct value of pi when nobody's looking. So this is what I want. I want to be able to import math, and then every time I access math.pi, I want to get a different value from the last time I accessed the variable. The idea is that the value is different every time you access math.pi. This way, I can program it so that math.pi gets closer and closer to the true value of 3 over time. And again, you might be asking yourself, why? Don't worry about it. Just go along with it. Well, the code should look a bit like this. Import math, store the initial value of math.pi, and now each time I call the pi function, it'll return a slightly changed value of pi. I'm not currently calculating a value that will get closer to 3. I'm just adding a small number to make the code simpler. So what does it look like to use this? So here I've imported my custom math module, and when I call pi, it returns a value that's slightly different from the time I called it before. It looks kind of close to what I described, but what are those? I have to call the function, and math.pi isn't normally a function. So I need pi to be a function, but I don't want it to look like a function when it's called. Just accessing pi should cause it to be executed, and Python has a construct for that. It's the property decorator. The only problem here is that property only works on methods attached to a class. It doesn't work on top-level functions. Okay, well let's go with this. I've put the function in a class now with a property decorator. Let's see how it looks to use this. So, first I instantiate the class to get my math object, and then you can see that it behaves the way that I want. Each time I access pi, I get a different value. Result. But this is wrong. I need to get this object by importing math. Let me introduce you to the modules dict in the sys package. Every time you import some Python code, the package is added to the sys.modules dict. To demonstrate what I mean, if I look up math in sys.modules, then it fails because this code hasn't yet been imported math anywhere. If somewhere in my program I now import math, then when I look up math in sys.modules, it returns me a module. And I can compare the module in sys.modules against the math that I imported directly, and they're the same. This is one of the reasons I like writing stupid code in Python. It's made easier by the fact that almost everything is mutable. And because it's mutable, you can change it. So, let's manually modify sys.modules and pretend that the code has imported math. But instead of giving it a module, I'm just going to give it a new math instance that we defined before. It doesn't care. I can put anything I want in this dictionary. Duck typing, baby. So, now I import math, but because it's in sys.modules already, Python thinks math has already been loaded, so it just returns what's already in sys.modules. And that is my new math object. And this doesn't have to be in the client code. This swap can be done when my dodgy module is imported. So once I've swapped my custom object as the math module, the real math module will never be loaded. Now, as long as my math helper module is imported somewhere in the codebase, anywhere that's importing math will get the wrong thing. So when they access pi, each time they will get a gradually worse value. So now we're done. But wait, there's more. I have a problem. It turns out that math doesn't just contain pi. It also contains a function called ceil, short for ceiling. If ceil is missing, then my colleagues may notice that I have corrected the value of pi. So I can go back to my new math class and I can implement ceil. I can just get it to call the real ceil method in the original math module. So now I'm done? No. I had a look at the docs for the math module and it's really big. Did you know that mathematicians had learned so much stuff? It was a surprise to me. At this point, I realised I was going to have to implement a stub for every single thing in the math module. So this stupid trick started to get a bit boring. And then I started to think about looping through the math module and automatically adding each of the things in math to my new math class. And then I decided to take a step back and think about what's going on here. Let's go back and have a look at my call to ceil. There are actually two operations here. The first is to look up the ceil attribute on the math object. And the second, once you have a reference to the ceil attribute, is to call that attribute, because that attribute is a method. What I need to do here is to change what happens when I look things up on my new math object, so that it passes those attribute lookups through to the real math module. Let me tell you about getAtter. It's a special method you can implement on a class. Behind the scenes, Python will call it if you attempt to access an attribute which doesn't exist on that type. So if I try to access lemons on an object that doesn't have a lemons attribute, behind the scenes, Python calls the getAtter dunder method with the string lemons. So I need to implement this method on my new math class and tell it that it should look up each item on the real math module. That way, if I try to access pi, I get my new modified pi, but everything else is passed on to the real math module. So let's go back to my new math class and replace my ceil implementation with this dunder getAtter method implementation. All this does is use the getAtter function. Note that this is not the same thing as my dunder getAtter method, to look up whatever item is requested on the real math module. There's some other stuff I should do to this class to make it look more like the original math module. I should probably get it to use the docs attribute of the underlying math module, and I should probably implement repr to make it look more like the real thing if somebody prints math. Feel free to take this code as a starting point and see how far you get. So what have I covered in this second half? Firstly, modules and objects are basically interchangeable. You have to manually modify the sys.modules dict, but that's basically it. Modules can't use the property decorator, but objects can. If you put an object where people expect a module to be, you can get behaviour that's unexpected. Almost everything in Python is mutable. Except some things that are implemented behind the scenes in C, it can be a struggle to change those, but it's just another challenge for you. And finally, you discovered how to magically create any attribute you like on request. It would be quite fun to implement this in a way that allowed you to misspell method names in your code and have things still work. This code, or something like it, is also on GitHub in a project I call Stupid Python Tricks. There's a bunch of stuff in there, including some more advanced tricks using things like metaclasses and directly implementing the descriptor protocol. But most of it takes advantage of things I've covered here today, modifying things you're not supposed to modify and using dunder values in ways they weren't designed for. You don't have to be a Python expert to write weird and wonderful code. You just have to have some time and the urge to be creative. If you haven't written stupid Python code before, on purpose, then this is just the start of your journey. There are lots of special dunder methods and variables you can play around with. Read the Python data model to find a list of most of them, along with what they do. If you don't know what the descriptor protocol is, go find out! It explains the rules for looking up attributes on objects and has lots of opportunity for doing weird things. It's the way methods work, as well as how the property, class method, and static method decorators work. Eval is lots of fun. You can build up a string of Python code at runtime and then compile it into executable code. I really wanted to cover metaclasses in this talk, but it's really not possible in the time that we have. I don't usually promote my own talks, but I gave a 70-minute talk on classes and metaclasses at PyCon Australia a couple of years ago that I think provides a pretty good introduction to how they work. The dis package allows you to disassemble Python code, like functions, modify the bytecode, and then reassemble back into executable code. It's a super advanced technique, but allowed my friend Sebastian Noack to add a goto command to Python. And finally, the way Python finds and loads code can be changed using importlib. This is also reasonably complex, but would allow you to import code that isn't written in Python into a Python program. There are so many opportunities to write weird and terrible Python code on purpose. Okay, so let me try to actually answer why I do this sort of thing. For me, it's an opportunity to try out a feature of the language that I may not have a use case for yet. It's a puzzle. You can work at it two ways. Decide what you want to achieve and work towards it, as I've presented in these two examples, or learn a new feature and see if inspiration strikes for weird and wonderful ways you can use or abuse that feature. I actually have friends online who I swap weird techniques with. I met these friends at conferences presenting unusual code, either because it's useful or for fun. So it can be a great way to meet new, smart and interesting people. But mainly, I do it just for the reaction I get when I show someone the code or post it on Twitter. I do it just because I love to hear someone say, "But why?" Thank you very much for listening, and I'm sorry for wasting your time. For more stupid Python tricks, follow me on Twitter. Thank you very much.